the title page. So today's session is about digital asset multi-party computation with Google Cloud Confidential Space. So we are going to run the Coffee and Cloud sessions on a regular basis this year. So if you have ideas, please email us at coffee-and-cloud@google.com. Next page. So a couple of housekeeping items. Number one, this session is being recorded. And number two, if you want to ask questions, please use the activities button that's at the bottom of your screen. It has like a triangle, square, and circle icon at the bottom, and then you can select Q&A, ask a question. Next page. So my name is Bertrand Portier. I am part of the Google Cloud Customer Engineering team and the principal for Google Cloud Digital Assets. Our mission is to support our customers' needs for building, transacting, storing value, and deploying new products on blockchain-based platforms. So now I will invite my colleague Chris to introduce himself.
Yeah, thanks, Bertrand. Hey, everyone. My name is Diya. As the title says, I'm a security architect here at Google Cloud. I focus specifically on trying to solve security challenges for cloud as well as digital assets. So looking forward to the session today, and nice to meet you all.
So if we go to the next page, a little bit about how we're going to do today's session. So we planned for like 20 to 30 minutes worth of materials, followed by a Q&A session. I'll start with a blockchain signature and transaction approval use case, then move into the solution overview and its benefits. Then Chris will cover the reference architecture and the technical components, and then we'll do a Q&A session. So this is where we invite you to unmute, ask questions, use the chat or the activities button with the Q&A feature. So at the end, we'll provide links to resources so you can learn more. So a couple of things before we move to the use case here. Just to set the stage, right? A couple of things. One, there are multiple use cases for applying MPC and using confidential space in the digital assets industry. But we just picked one of the most common use cases. And two, we also want to know about your needs and your experiences and use cases for MPC. So when we get to the Q&A session, please be ready to share and discuss with us. So next page. So this is our critical user journey, right, to bring the solution to life, typical of an institutional custody wallet or similar environment. So on the left, you have Lily, who works for Bear Crypto and is submitting a digital asset transaction to send funds to Terry, who works at Crypto Magic on the right. According to policy, Johnny, who is in the middle, needs to approve that transaction. When the approval conditions are met, a blockchain transaction is signed and submitted to the blockchain, for example, to like an Ethereum node. So Lily, Johnny, and Terry can do this efficiently in near real time and according to policy. So if we move on to the next page, right now we get to see the overview of the solution and the benefits. So first, a little bit of background about like situation about where this fits in our bigger portfolio, right? So what we wanted to do is to really raise awareness about implementing MPC in GCP with AMD Sev, right? And that is using Google Cloud Confidential Space. And also what you are going to see in terms of an implementation is very oversimplified, right? For example, like you will see like how we oversimplified the threshold policy, the key generation, or the key management. But our expectation is that companies like yours are going to provide like the real production-grade implementations based on your needs and your products. So if we start from the right, and with the picture, so we have an unsigned transaction that's coming in, and it's coming to the Trusted Execution Environment, TEE. So this is confidential computing. This is hardware-powered encryption of memory, data in use, in confidential space. At the top, you have cosigners like Lily Journey and all different companies coming from different companies even who use their key shares to sign and interact with the trusted execution environment. And then the output on the right is an MPC compliant signed transaction that is submitted to blockchain. So you see at the bottom, we make that point, like the main difference right between multi-sig and MPC is that with MPC, individual keys are replaced by key shares, and that removes single points of compromise. And then on the left, we listed a few benefits, right, of MPC enabled by confidential space. You can transact in real time without requiring cold storage, even though cold storage is supported, right, for backup keys, etc. You get an institutional grade solution with user interface, safeguards, etc., while keeping control of your private keys. And the signature process is auditable and policy compliant. And last but not least, confidentiality. It respects the confidentiality of key materials. And that's why you're going to see a lot more about this, right, in the next few pages. So key materials are not exposed to the other parties or to the MPC operator. So that was a little bit of a fast, right, high-level overview. And now I'm going to pass the ball to Chris, who is going to cover the reference architecture.
Yeah, thanks so much. So I'm going to start with covering some of the technical detail. We're going to dive into kind of lower detail on how the solution works from a technical perspective. And then I'm actually going to come back to the reference architecture diagram to kind of put it all together, because if I don't get into the technical detail, this reference architecture diagram over here may not make a ton of sense. So let's start with kind of the different components and the capabilities that we deliver. So first and foremost, the solution that we're kind of proposing is based on a service that we've launched called Confidential Space. Confidential Space at its core is built on confidential VMs. And so just a quick kind of background on what confidential VMs are here in Google Cloud, and why they're different from alternative options out there. So our confidential VMs are based off of AMD's secure encrypted virtualization technology. And we encrypt the contents of memory on a per VM basis. It's not a single key that encrypts all VMs with the same key, but it's done on a per VM basis. Those encryption keys are generated by AMD's secure processor and are ephemeral in nature, again, on a per VM basis rather than across all of the VMs on a single instance. The keys themselves cannot be exported out of AMD's secure processor. And if it's not immediately clear, AMD is ultimately responsible for generating the keys. They're ultimately responsible for the code that goes into secure key generation. Google does not have a say in how those are done, and Google does not have a view or control over the keys that are generated by AMD's secure processor. So not only are those not exportable to customers or users of the platform, but also not exportable to the cloud provider, in this case being Google. So essentially what we're doing is we're providing the protection for data in use from a couple different aspects. One, the hypervisor. It doesn't rely on the hypervisor implementing this technology and does not provide any sort of backdoor access to Google's hypervisor itself. We also provide protection of data in use from Google themselves. So as I mentioned, Googlers do not have access to export keys out of AMD's secure processor. And then lastly, it also provides, cryptographic isolation from other customers. We obviously have many mechanisms for providing isolation in a multi-tenanted environment, but it's good to have a cryptographically verifiable isolation mechanism in the form of, again, confidential computing. So that is kind of the underpinnings of what confidential space is. And it's, again, based off of confidential VMs, which is part of our confidential computing portfolio. Confidential space takes the confidential VM notion one step further by providing protection from the workload operator itself. So if you think about a confidential VM, it's pretty cool that we're doing encryption of contents of memory at the VM level, but it still leaves open the risk that if someone has access to the VM, that you then have access to either modify or exfiltrate data, either modify the workload at runtime or exfiltrate data from either the workload or from contents of memory that happens to be loaded in there. So that's where confidential space steps in and provides, again, that protection from the workload operator itself. So in this model, what we're doing is we're verifying the parameters of the workload, essentially like how it's launching, the commands and parameters that are put in when you launch the workload itself. We're also verifying the operating environment itself. So ensuring that it's loading from, again, a confidential space VM, and that it is loading with all of the correct controls in place. And I'll get into kind of what that means in just a second. And kind of by nature of that, we have those strict controls in place to ensure the workload operator themselves only has very basic access to what they can do to the workload. Essentially, that's start the workload, stop the workload, restart the workload. Again, as I mentioned before, the workload operator cannot exfiltrate data from the workload, nor tamper with that workload during runtime. And lastly, confidential space kind of completes this picture that we're talking about here to provide the means to cryptographically attest to everything essentially that I just mentioned. So it's great that we say this, but how do we actually prove it in a verifiable way that you can actually verify this yourself? So that's where the attestation service, which you'll see in just a second, kind of comes in. So not only do we verify these things, we make them remotely attestable. And we also can take those to grant conditional access to sensitive data, whether that be keys or, for instance, encrypted data in a cloud storage bucket, or any number of things that accept conditional IAM policies within Google Cloud. So if I flip to the next slide and talk a little bit more about the details, and then I will go back and talk through the reference architecture and how we kind of anticipated these tools being used in a solution type format. So again, kind of the components of the MPC solution that we've proposed start with the trusted execution environment. I talked a little bit about confidential VMs and what they are. Confidential space, as I said, builds on top of that. So you've got your confidential VMs, and then you've gotten your essentially hardened OS image and kernel on top of that confidential VM. So as I mentioned before, confidential VMs are just simply leveraging AMD Sev, and I have many different options from a workload and image perspective of what I can run on there. We don't provide a specific opinion or a specific image that constrains what you can do within a confidential VM. Confidential VM is simply the security controls we put in place to ensure confidentiality for that VM. So where does confidential space come in? How do we provide these additional guarantees? Part of that comes with the hardened container optimized OS kernel that we have. So essentially what we're doing there, we already have container optimized OS. And if you've built anything in Google Cloud, you're probably fairly familiar with what container optimized OS is. Essentially, it's a Linux distribution that we build and maintain based off of Chromium OS. And it's essentially, as Chromium OS is, very stripped down, kind of bare bones OS image that is very focused on launching containers themselves. So some of the security guarantees that we provide for container optimized OS would be things like an immutable root file system, a reduced set of packages, again, optimized to run containers and containers alone. We remove package managers. We do not allow execution of non-containerized applications or any sort of binaries outside of the container parameters themselves. And we also don't load any third-party kernel modules or drivers. What container optimized or hardened container optimized OS provides on top of that, we require a single container per VM. So you essentially have the guarantee that there's only a single container running within a confidential space VM. We disable all remote access, so no SSH or anything like that into the instance, as well as provide additional boot measurements and disk protections, both from a confidentiality and integrity perspective. Again, ensuring that essentially you have a data clean room or clean box or any other number of terms that you can use for a trusted execution environment where essentially data can go in, but nobody can modify or work with the workload at runtime. The next piece is the attestation service. I'm going to skip over workload because I've talked enough about AMD Sev. The attestation service itself, As I mentioned, we partner with AMD on this, and we have our virtual TPM as well that will look at the at many different parameters, the boot parameters, the parameter of how the workload is launched, the parameter of the operating environment itself. Is it running on SEV? Again, verifying the boot measurements and some of the other things. And that attestation service will verify and sign and mint OIDC tokens. Where that's useful for is I can use those tokens in IAM policy, specifically conditional IAM policy. So I can use something like a workload identity pool to essentially grant access to a certain identity based on the presence of the attestations that I've provided previously. And that's one of the great strengths of confidential space, and where we see it become extremely useful from an MPC use case, specifically transacting digital assets. And then the last piece, the last component to the solution is the protected resource itself. So once we've set up a secure environment, provided attestations, and given you the ability to leverage those attestations to access protected resources, we can then extend that capability out to the different protected resources. And again, I mentioned things like accessing the KMS API, accessing cloud storage, any number of different services that I can access. Again, all based on kind of core competencies that we have from an IAM perspective and a workload identity perspective within Google Cloud. So again, as Bertrand mentioned early on, we've kind of targeted a specific use case, but it's extremely flexible in that it can be used in many, many different ways, perhaps in many ways that we have not even anticipated yet. So now if I go back here to the reference architecture itself, how do we tie all of these fancy things that I've talked about together to actually produce a solution? And this is kind of what we've kind of put together and kind of want to walk through now. So essentially what happens here is I will create a container image. That will be the workload itself. I've alluded to kind of what the workload is, and I've kept it very vague because, again, there's many different use cases. But essentially, from a signer perspective, I will have kind of a transaction workload here that's essentially going to ingest an unsigned transaction, make a call out to different parties to get approvals, and provide key shards to validate the transaction and actually go into the actual signing process. And then the last piece of that would be actually submitting to a blockchain node, submitting the signed transaction to the chain itself. So it all starts with the container image itself, the workload. And this is where Google and myself and Bertrand and the rest of the team have not provided an opinion on what that workload is. So our goal was to build the infrastructure underneath that you needed to build your applications on top. We have not built a custody solution ourselves, nor are kind of saying what needs to be done from a workload perspective. So that's left entirely up to you. We are working with different partners in this space. So that could be something that we take as a follow-up if there's interest in kind of getting connected into, hey, I need some help kind of starting with how do I build this workload. We're happy to make those connections for you. But essentially, the container image then is created and is able to be verified within something like Artifact Registry. You can use other registries. It just has to be something that the container optimized OS and confidential space VM itself has access to. Essentially, the image is then going to be pushed and used to stand up a confidential space VM. And the confidential space VM will be told what image to pull from and what launcher parameters we have for the container itself. It will then, as it runs, query out to the attestation handler and the attestation service itself, and leverage the TPM to attest to the different criteria. Again, the digest of the image and the parameters used to launch the image into a container. The operating environment itself, so the presence of SEV and the current policy version and things like that. The VTPM will validate all of those and sign the OIDC token, so that when the workload runs and needs to make a call out to another Google Cloud service, it can do so with the presence of those claims. So next, in our kind of solution that we built out, we'll make a call out to KMS in this instance. We've kind of put together the notion of creating a signed transaction using KMS, keys resident in KMS themselves. That doesn't have to be the case. You could leverage KMS where the right algos and curves are supported, And where they're not, you could leverage a different service, either keys you've created on your own securely, and potentially keys that you have resident in yet another trusted execution environment, yet another confidential space VM. So that's why we've kind of built this out with a little bit of flexibility to it. And I could also have keys or key shards sitting out in other places and signed by KMS. So the call could be to KMS as well as to the data source to pull the signing pieces that I need, as well as decrypt via the KMS key that I've encrypted them with. Once I've done that, once I've made that call, I'm going to go through a policy check. What identity is being presented to run that operation? And does that identity have the permissions to do so? Does it also present the attestation claims that you've specified in policy to allow you to make that call? Again, making sure that if I'm calling KMS, that it's being done only from this trust execution environment through the identity of the trust execution environment, as well as the claims that the VTPM has provided before. Once all of those have been verified, only then will the access to the material be made. And that access to the material, again, can only come from here and will never be accessible outside of the trust execution environment, nor is that data ever leaving the trust execution environment itself in an unencrypted state. Once all of that operation has happened, then we sign the transaction and submit that to the blockchain node. And there's a couple options there as well. We have a blockchain node hosting engine service that we're launching, as well as if you choose to roll your own nodes, you can do so as well in Google Cloud Compute Engine. So that kind of completes the entire idea that we had, going from a submission of an unsigned transaction all the way through to signing the transaction and submitting to chain. So with that, I will take a pause and see, are there questions and things that we can kind of answer?
Yeah, we have a few questions in the Q&A. Thank you all for submitting. Maybe let's see if we can share those. I don't know, Moy, or if you can access the questions in the Q&A, maybe show them on the screen. But there's one from David that's high level. Maybe we'll start there. Love this use case. Thank you for sharing. Are any of the advancements that made this practical a step to achieving MPC level security or encryption at real-time performance for all compute applications, not just transactions? I think that is spot on, right? So like when we look back and when we launched confidential virtual machines, confidential VMs that Chris talked about in 2020, what it was like a solution to keep data encrypted while it is being used in memory, right? So that means that we have the whole thing now. We have data encrypted at rest, in transit, and while in use in memory. Now, we still have a few challenges with that, which is more around collaboration and multi-party. And that's what we are doing here. It's like we want to remove some of the tensions that come with sharing data in a regulatory environment and encouraging collaboration while keeping your own data private. And that's really what we want to do here. And that's when you start to think about this, we have many use cases that are possible. Companies have started to use confidential space for things like doing joint data analysis and machine learning, like training models with the guarantees that Chris described, that your data is still your data, right? And you can keep that, the integrity of the data and the confidentiality, and it's protected from other partners who participate in the learning accessing that data. Right? So yeah, this is just one use case, and there are many other ones that are really applicable to digital assets and even broader.
I was going to answer real quickly the next question there, which essentially is how does Google work with organizations looking to get regulatory approval on deployments within an architecture like this? I like this question a lot. This is, I would say, a work in progress. So what Google does today is we do work with regulators and work on behalf of customers and with customers to gain compliance and regulatory approval for certain things. I would say MPC is pretty new and ever changing. And so I think it's definitely something we want to undertake, and we probably need some help to do so. I think part of it comes from, as I'm sure it does within your own organizations, with education. We need to make sure we educate folks like the enterprise trust team that we have internally to understand what problems we're solving and kind of the current landscape. And then we kind of partner together there with customers specifically to kind of work with regulators on these types of things. So I would say it's a work in progress. We're happy to kind of partner with you on that for sure.
We had one on the, I think, MPC. Which MPC algos are you supporting? Are there thresholds customizable or flexible without policy? For example, 3 out of 5 threshold be adjusted on a given condition to become 2 out of 3. So this is like in our implementation, we did like a very oversimplified threshold policy, and that's why we want to left it to you, right, to build the threshold policy and environments, right, that meets your need, right? So we left it open. We are going to publish very soon a code lab that goes through the architecture that Chris described, and you will see in that one that we really simplify the threshold aspect, but we wanted to show, right, all of the aspects of the architecture where the trusted execution environment provides in terms of attestation, integrity, and confidentiality.
Yeah, and I think just to kind of reiterate, like we've kind of left that open to you as users kind of dictate. And again, where help is needed from hey, we need SDKs to help us define policy and build out kind of a signing flow for different chains. That's where we can kind of partner together with some of the folks we've been working with to kind of help you there. But we don't dictate specifically the policy itself right now. In addition, so this kind of gets outside of confidential space itself, but if we think about it from a KMS perspective, one of the things we can send over after the call is kind of the encryption algorithms and curves that we support for KMS particularly. It's, I'm sure most folks on this call probably seen it, but it will be the curves that are supported by NIST, supported and approved by NIST. There are things that we're doing from a forward-looking standpoint to maybe extend that a little bit. I don't want to get into too much detail because it's still very much forward-looking, but happy to get into that on an individual basis later on. But I do see a path where we kind of extend some of that out so that if your choice is to have your key and key shard generation done in Google, that we have a place for you. That's our ultimate goal there as well. Let's see, the next question, policy engine. Is this cryptographic parameter embedded into MPC, or is it more like a filter that prevents signing and requires approval mechanism? Yeah, good question. So ultimately, we see that as being kind of a pairing that is dictated both by the workload itself as well as confidential space. So 2 things there. One, the workload itself will need to dictate who the signers are and under what context they can sign. So if you think about kind of a traditional multi-party custody as well as transaction flow, typically you're going to set up multiple users and user-based identities as well as devices that are going to be responsible for approving and signing. And you may even leverage kind of the cryptography from those devices to help with the signing if you choose to do that. So that would be the first part, is the workload itself will need to be kind of the first line of ensuring that the right approvals have been met and policy is followed to then sign. The next step from there is kind of where confidential space and some of the things that we've talked about in our solution comes in, which are, we will not allow access to those key materials until your workload authorizes us to do so. So your workload authorizes us to make a call out to KMS, for instance, to decrypt some secret material. And that will only be met if your workload authorizes it. Likewise, the platform will only do it if you've authorized it based on the workload identity itself. So if the trusted image itself has been verified and the operating parameters have been verified, only then will it make a call out. And this prevents the operator themselves from being able to access that key material under any other circumstances. You can point to and show and prove that I have built an IAM policy that only grants access to do like the crypto key decryptor role for this specific identity, which is tied to the workload itself. So that's how you can kind of provide that. And that's how those two kind of identities and verification mechanisms work hand in hand. And the next question very much focused on MPC algos. Again, I kind of go back to the flexibility of you kind of building out the application itself. So we're not currently supporting these MPC algos themselves, although would love to get into that space. That's more from a personal standpoint than Google saying that. So I just want to clarify that. That's a Chris stance, not a Google stance. So yeah.
And we had one at the very beginning of the Q&A as well, Chris. That's probably for you as well. But yeah,
oh, yep.
Encryption.
Thank you. AMD encryption. Do we know if AMD has a master key for these keys? In that case, for that instance, AMD has a physical access to these machines. They can magically decrypt all these keys with the root key. So that's a good question. AMD, we have a good paper on how AMD generates the keys and puts them onto the secure processor. I don't want to speak to exactly how AMD does it, but we will take an action item to kind of send that information over after the fact. So I think our physical controls are pretty solid in that AMD does not have access to the confidential VMs, nor the hosts that they ride on. And it would take a very strange circumstance for AMD themselves to gain access to that. So yeah, everything kind of in its layers. But I'll make sure we kind of follow up with more information on how the secure key generation is done from an AMD perspective. That's a great question. And by the way, in the follow-up, we'll also include all the materials we've presented today. As Bertrand mentioned, we're publishing a code lab that we'll make sure everyone has access to once that's public.
So yeah, maybe we can show a little bit of the links, right? We have next on the next page, right? That's what you're going to have access to, and there will be more in that space. So that if you follow us, right, on LinkedIn, etc., you will see even more of those, more publications there. Hands-on, a code lab is like a hands-on tutorial, right, where you can actually implement this yourself in your Google Cloud environment. I think we went through the Q&A. I am very interested in your thoughts around, like, what do you need around MPC? What are the use cases? What is it that you would need from Google Cloud, right, to make those possible and a reality? Or any other comments or questions you have? Yeah, just unmute and or use the chat if you'd like, or unmute, and we can have a small discussion. And if you'd like, we can even reconvene. Like, the idea as well was that we could meet, like, with this group, like on a monthly basis, and start to share experiences as well, right? So if some of you also wanted to talk about how you've used confidential space, or how you've used even on a different topic, not just security, right? We could do that as well if you're interested. Scalability of container provisioning. Okay.
Sorry, was there a question there? Go ahead.
Oh yeah, thanks guys. Great presentation, Chris. And it's been, sorry, I'm asking probably a lot of not so smart questions probably. So, and thanks for properly handling them. One of the use cases that we are facing is having this social recoverability through MPC, basically in digital asset space, basically. And what does that mean? That means if you have a wallet, or if you're a wallet provider, your use case is that the people who are going to use it, the users, they want to add their trusted parties to that wallet. And that brings us to like multi-signer functionality. I don't know how you guys would handle that. Given that you're not providing MPC yourself, I was interested in if you have seen any use cases where instead of a single signer, you also have like key refreshes, and those keys are also act as like signers. And how do you store and deal with them? Is it compatible with your environments and so forth?
Yeah, do you want to speak to that, Bertrand, or would you like me to?
Oh no, I was just wondering if you guys have seen any. No, Chris, this is not a. This is more like a conversation. I was wondering
Sure.
if any of your existing clientele, let's say, if they are interested in such functionalities, because we're seeing a huge demand to it. But it's a really challenging problem. How do you do key refresh and pass it to others, basically? So
Yeah, absolutely.
Yeah, that's true, right? And that's where, right, that's where I think partnerships would make sense, right? There's like what we looked at today was more around like the actual signature, right? You use your key share, right? You co-sign, and then in the MPC environment, it creates the actual blockchain signature, right? But then there are, to your point, there are many other aspects that are also required in terms of key generation, right? Key generation, right? Those key shares, you don't want them to be in one place and then split. You really want for them to be generated like in different places, right? And then you have rotations of these key shares, etc., distribution, and then you have, to your point, around the MPC and the threshold, right? The updating the threshold, right, based on what's based on maybe transaction types, etc. Or so there are many things around this, right, that need to happen also at the application level, right? And what we wanted to show you here is just like the beginning of what the infrastructure would provide.
I was going to ask a question real quick, because to your point early on about asking questions, I think like this is a new space, and we all need to be asking each other questions. I think one of the things I've come to accept as an engineer is that along with being an engineer, the job requires you to be very humble about the things you don't know, which for me is many things. So I'm curious, because we've seen different patterns where different devices are being leveraged to create the keys or the key shares themselves. I'm curious what the folks in the community have seen, whether that's leveraging a different kind of software-based workload that would do secure key generation unique to you within, say, like a cloud provider or even on-prem. Are you seeing perhaps modification of like an HSM type device, or leveraging an HSM type device, whatever it may be, to do the secure key generation? Or are you seeing a reliance on, to your point earlier about identity, like a mobile device that's been verified to be attached to a specific individual and doing that? And maybe it's not a one answer that fits all. Maybe it depends on the use case, but I'm genuinely curious what people are seeing out there.
I'm willing to share. I mean, just in practice, the thing that I've borne witness to in this, particularly with customers adopting Google Cloud, is that every one of those use cases you just mentioned, Chris, seem to depend less on the technological preferences of the client and more on the regulatory demands of whoever they're trying to get licensed by or audited from. And so, like, where we wind up focusing our attention with our clients really centers in what is it that we have to work backwards from. So, what are the regulators telling them to do? What, from a technological perspective, that's within the confines of that, and then engaging them accordingly. So, like, the bummer I run into is that when I see use cases like the one that you demonstrated today, I love it. And that puts me in the position of saying, how do I engage correctly with clients to help fit that solution in the confines of what a regulator is going to say yes to? And so that's really where I find the majority of my attention being spent.
Yeah, very good point. Yeah, and very similar, right, for us, David, like not surprising. And that's also why, sometimes it takes a little bit longer, right, to have these Web3 schemes supported, curves, etc., right? Because like our KMS runs in a FIPS 140-2 compliance mode. So you need to have those, right, like attested by NIST, etc. So yeah, I think we are in a very similar environment here. I think, Brandy, you had your hand up?
I did. I'm patiently waiting here. This is super interesting. I feel a disruption is going to occur. I really do. And when you think about this, it's like mobile wallets are right there. They're going to be looking for secure path ahead as adoption continues to foster in the space. I mean, it's clear that the space needs help. One area specific, though, is like Gnosis Safe. Most of the projects that I've incorporated with, either from client-side front-end services to back-end integration, Gnosis Safe is typically a go-to. So, this helps like provide a new option for folks, and I think it's very intriguing. I asked a question earlier, and it's limited, and I just want to dive in sometimes. I get like super energetic about these solutions and where they can go. My question is more on the blockchain node engine. Like, I'm thinking full circle here. Like, let's say I do have a project that's integrating services on the back end and also providing front end services for consumption, client consumption. How do we prepare compatibility for blockchain node engine? How does a chain participate on that? More specifically, EVM is pretty much standardized right now. Like, Geeth is known as the go-to. As far as I'm concerned, one of the most matured offerings in the space. So when we think about Geeth specifically with blockchain node engine, is blockchain node engine utilizing the standard RPC parameters for the provisioning of containers, or is there some special hooks occurring that requires compilation of Geeth to be compatible for blockchain node engine?
Very, very good questions. Yeah, and very connected topic. Maybe we do even like a follow-up on node hosting, node engine, etc. Right. So, so the context behind the node engine and running your nodes in Google Cloud is that you have options out there to use like shared nodes, but at some point you need to have your own dedicated nodes, right? And that's when you get to blockchain node engine. Blockchain node engine is going to be the fully managed offering for your dedicated nodes, and you also have the option to run your own nodes in Google Cloud using Compute Engine, Kubernetes Engine, etc. So you have these two options. Node Engine as a starting point, right, is getting released, and you can see in the announcement, right? But and the GA is going to support Ethereum, right? Ethereum node, full nodes, right? So that's going to be there, and then very, very quickly we'll move into like archive nodes and this, and also right related to validators, consensus, etc. We're also going to move on to support other protocols, not just Ethereum, right? In blockchain node engine, that's going to be important as well. And then you have connective tissue, right? Connecting what we talked about today, which is more around custody, right, and key management to these nodes, right? So maybe one of the nodes is a validator node, right? And you need to manage, right, the validator keys. That's super, super important, super critical. And you could apply, MPC compliant signature to manage those validator keys. Does that help, Brandon?
Yeah, I'm just so did I hear correctly that the blockchain node engine is fully compatible with Ethereum right now, or is that still to be determined?
It is and we support the full node as part of GA, and then expanding to different types of nodes.
Okay, and then the archive node, that's to come. That's a feature to come for the provisioning side of node service.
Yeah, that's going to be like pretty soon, right? Yes. Mm-hmm.
And that's why I asked the questions, because when I think about that makes me think that Geeth is being custom compiled to be compatible for the provisioning service side. And that's where I was like, I'm really seeking to learn a little bit more about that, because I've done some integration work with Layer 1 and like Chainlink and so forth. And I've used Google Cloud Services a ton for like things like soak testing. So that's why I'm asking these questions. I'm thinking about the full circle. I help out a lot on the integration side with like various, I don't want to name them all here, but nonetheless, I've done a lot of work on the back end and front end side. And I just want to help folks best utilize these services. Like MPC, I think is it's going to get widely adopted. And I would like to be a proponent of being a front runner, supporting folks on that.
Amazing. Let's get that schedule right. Maybe at the following session, right, or one of the following sessions, to the deeper level node engine, right? Compatibility and all different types of nodes, etc.
Awesome. How do I keep a pulse check so I can stay in tune?
Yeah, like I saw somebody propose the idea of let's meet regularly. I love that idea.
Me too.
Collect the folks that have been registered for this session, and we start a kind of monthly or however we determine sync up, and we talk through all these things.
Like a user group.
Yeah, exactly. User group. That's the word I was looking for.
Love it. Thank you, guys. Really looking forward to this. And I'm hoping that as we do regularly meet, maybe I can help provide some value add. So folks, just know I believe in knowledge is meant to be shared. If there's anything I can do to help us out as we meet, I'm open to that. So really good. Thank you so much for supporting all.
Yeah. Thanks, Brandy. Yeah, we would love that, right? And like it's not always like us from Google presenting, but like we are sharing, right? And yeah, that would be great. Let's see if we have any other Q&As.
I see there's some back and forth about zero knowledge proofs, homomorphic encryption, differential privacy. There's a lot of good topics there. So, you know, from an MPC perspective, MPC relies on, or in the way we've implemented it, and I would think any way that you do it securely, relies on encryption of data in use and even integrity of data in use. And so we've kind of done our best, I think, to kind of propose how we think that can be done. But it's certainly not the only way, right? Like in some of the technologies that you've pointed out. I think it warrants probably a separate session to dive into more detail on each of these. One of the things that we're doing from a Google perspective and from a cryptography perspective is we're constantly evaluating and kind of contributing and even leading the industry in many situations on some of these things. So we recently put out a paper on post-quantum crypto. And I think as we continue to evolve and get into some of these technologies, you're going to see more stuff kind of coming from Google. Nothing that I can share today, but I think we keep the conversation going on some of these other alternative options as well.
Hey, Chris, I wanted to come back to your question about use of the hardware devices, right? Like, so I feel like that didn't get addressed. My experience so far is that there's like hybrid solution based on the use cases. So if you're really targeting as a company or as a solution, if you're targeting more like end users, you know, like small to medium size, you know, entities, it's more a reliance on iOS or some sort of a mobile device where like the lead key share gets generated. But if you're really going after enterprise or big custodial solutions and so forth, they rather prefer what you're saying, right? Like SGX servers or some sort of an HSM or things of that sort that's on premise. But I think the issue that I am seeing is that it's not just really technical, it's more of a regulatory problem, which is why I was asking the AMD question, which our clients ask to us basically, where they wanna comply with regulations. And for example, if they don't want to hold their keys in US, right, and they want to make sure that none of the secret information is accessible by any party, right, like in that including Google or AMD or so those are the assurances that you need to kind of take as you go bigger. But like for our company, it's not an issue, but I know for larger institutions, it's probably an issue.
Got it. That's good feedback. That's good feedback. Cool. One of the things I did not mention, I'll mention it. You mentioned SGX, which I don't think I brought up in the discussion. There's obviously other technologies out there, right? AMD SEV isn't the only one. AMD's even got, you know, SME, TME, kind of as SEV becomes a subset of those. TDX is on its way. There's a whole bunch of different technologies out there. We've chosen to start with SEV. We kind of looked at and analyzed, does it make sense to standardize an SGX or at least have an SGX offering, and decided not to go that way for many different reasons. One being just kind of Intel has kind of aligned on TDX as kind of the path forward. And so at this point, it didn't make a lot of sense to get behind the SGX train. I think, you know, with some of the security vulnerabilities and the lack of scalability with SGX enclaves particularly is, I think, what kind of led Intel towards TDX. And so, you probably say this in a way, since we're not under NDA, you'll probably see something from us in that space at some point in the future. Maybe that's the most vague way I can say that, without making any promises. And you'll continue to see us evolve from a SEV perspective as well, with some of the newer technologies that have come from the SEV chain of functionality as well. So more on that to come, and as we kind of get the working group going, we can share more of that, I think, in more detail.
Okay, I think that's it for today. And this is amazing. Like, we're going to meet on a regular basis. We're going to share, like, collaborate. So thank you so much. Thank you. And then let's meet again in about a month from now.
Sounds good. Looking forward to it. And you're going to do a follow-up email with the resources and a summary. I would love that. Thank you so much, you guys. Super cool. Can't wait to see this shape moving forward. Have a great rest of your month.
Yes, thank you. Bye-bye.
Thank you all for the time.